2, 1.
Okay, started now.
Okay, yeah. So Jayson, today I'll show you a bit how our model for Indonesia is built. We'll try a few things out together.
Okay.
I thought we'll start a bit with the facade of the building. Well, let me load a favorite for that, because we don't have to make it more difficult on ourselves.
Yeah.
We can just load a favorite. Then all the necessary files and necessary floors of the building will be activated at once. And we activate the drawing file for a facade. So close that. So this is our current result. We already have quite a building, but you see that the facade here in the front is actually missing. Our customer requested to have a spider glass facade in this position,
Okay.
which is not too complicated in Allplan. We can just add that like we add a lot of like we add a regular window.
Okay.
So see, we are here in the architecture module, and we have a lot of different elements, walls and so on. But we also have in the opening elements category a facade we can add. So we click this facade, and Allplan allows for a parametric creation of this facade. So we can choose to add different style of elements. Here the spider glass is already added, so I will leave it at that. Between here we can load different kind of favorites that Allplan predefined, but we can also make a facade ourselves with this surface line or point object creator. So a surface would be the glass, a line would be all the tendon cables between the elements for the spider glass. Luckily, Allplan provides us with spider glass out of the box, so we don't need to make it ourselves. The next thing we need to decide is where do we want the spider glass? We want it in the front here, and you see that I am editing in this 2D view, but you can see the point as well in the 3D view on the right side here. And how we want the elements of our facade to be scaled. Do we want them periodical? That means that we want a new facade element every 1.357 meters in this case. Or do we want to scale it according to the height that we will have our element be? In this case, I want a new window every 1.3 meters. So I pick the periodical option. If I would pick scaled, then I would have one big window from the bottom to the top, depending on my settings.
So you mean the scaled here is actually dependent on the height or level of the...
So I have a height here, it's 3.35 in this case, here on the top. If I would pick scaled, the element would be 3.35 meters high.
Okay.
If I pick periodical, Allplan tries to divide the element
Based on
the settings.
dimensions.
Yeah, based on the dimensions. Now I clicked scaled and then periodical, and I lost my settings. This could happen, but that's no problem, because you can always load a favorite from before, and you see that the setting comes back. Right. So this is an easy way of working with Allplan. Yeah. Now, I want my spider glass facade to be from this left side of the building, so let me click here, all the way to the other side, and you already see that Allplan is generating a preview. So let's go and click this point here, click escape. We have one problem now. If we go out of the function, you can see this is our spider glass, but it's only 3.35 meters high. So let us check how high it actually should be. For that, we can use our measuring tool, for example, and measure the length between the highest point here and the lowest point here. So we see that it should be 17.38 meters. So let's also enter that in our facade. We can, as it's a parametric element, we can just open that and now enter the facade height as 17.38.
Yep.
And this is our result. So the bottom parts are all 1.35 meters, but the top part is a bit smaller, and Allplan will just start a new one and stop when it's necessary. You also see that the spider glass continues up to here with the correct elements all the way around. In my spider glass favorite, I also created a door. You can go in the object definitions and you can add multiple surface objects. You see I have a door on the left, a door on the right, and some tests I made at some point. And these have been added automatically by going here in the settings. So if we check the subdivisions or the layout of our full window, we see that at certain positions in our window we have a door defined. So the door left would be at the 4th position and the 5th position. This can be easily defined either on the left here in this Excel-like table, but easier is maybe to define it right in Allplan. If we click on the plus sign here, we can add doors everywhere we want, but it wouldn't make sense, of course, in this case. Yeah.
Okay.
So let me quickly close that, and we see that we have a nice door element as well. Okay. Do you have any more questions about this part?
Well, actually, there's nothing much. Just curious how long it takes for you to create the door?
The door, so what I do first is you go to the opening elements.
Okay.
Click here on door, and then you would create a door somewhere. If you escape out of that, you see that at some point in the past I have already made a door like this, and then you can just import this door into your facade object. So creating the door, so this door element is also parametric, just like the facade. So if I would go into the door options, you would normally see some options. Okay, let's do it different. So this door element is actually also a parametric element. You can double click on this door and then you will see some settings about how it's created. So every element is adjustable. Right now this is a window, but if I click it, it's glass, you see here. I can also make it leaf, I think, and close that out, and now it's a door without glass. So now it's a wooden door, for example, or a metal door, depending on the material you chose.
You can choose. You can put some materials as well, right?
Yeah, you
Okay.
can put a lot of materials on every element. So this, in this case, of course, is metal, and the door was glass. Right now, I've created this kind of object, or this kind of handle on the door, but any handle can actually be chosen by just going into the settings and changing it. So let me see where that is. Here you have, by example, the type of material for the handle, in this case aluminium, and you can actually choose any kind of thing. So we have handles here on the bottom, and depending on which element you click, handles will be defined. So the handle is defined on the corner of the door, not on the glass.
Okay.
You can also choose differently and then adjust the position accordingly. It's up to you. You have different options that are predefined, and you can of course also make your own.
Okay.
Okay. Now let us maybe continue with creating some special facade, because you see
That's an interesting facade.
yeah, it's quite interesting. Well, this is of course not something that's available out of the box. Not everything can be, but it's something that you can easily create in like 30 minutes.
Okay.
Provided you have some inspiration and some creativity to make something special. So how would you go about this? Let me quickly open one single element of that. So you see that everything has been categorized. So this is the visual scripting facade. If I double click it, I will just only open this. And these elements we actually call Python parts, or visual script Python parts, because they are created by just scripting in a visual way.
Okay.
How does that look? Well, if you go into the user-defined object, because it's something I will create myself, you have visual scripting. And the picture already defines quite well what visual scripting would be. It's just boxes and arrows. So we are connecting these boxes which have a certain input and a certain output, and we connect them to different boxes, and each box does something.
Okay.
For example, this is the script for the facade we have now, and you can easily create some groups to make it more easy for you to read. There are some inputs, and then some calculations happen, and in the end we will have an output of some geometric elements, in this case a subtraction, because we are actually just going to create a wall and subtract some circles from it to make this kind of facade. This is of course a simple example, could be much more complicated, but this is just a starting example actually. So either we click the play button here in Allplan to create something, or we can also just in the library select the element. So let's go ahead and select it in the library, because it's a finished element. You can go to the library here, go to private with some visual scripts which are not there. 1 second. Need to find them.
It's in the office?
No, it's it's in the project. Yeah, I forgot about that. So we go to let me start from here again. So we go into the library, and then in our project, which is this one, we have a visual scripting folder, and this visual scripting folder gives us a few of the visual scripts we made. We also have one for MEP. We'll talk about that later. But for now, let's try this architectural facade. Now, on the bottom of the screen, Allplan is asking us to click some different points. From point, it says. So we can either click the points in 3D, or we can make it easier on ourselves and click some points in the 2D plan view. So let's do that. Doesn't need to be a whole lot. Something like this, for example, and we click escape. The moment we click escape, depending on how your script has been built, you should see something. So right now you can see the element is at a certain height. Why is it at a certain height? Because top height and bottom height are defined here. Right now for this simple script, they are defined manually. So if I would put 0 here, then the element would become a big block of cheese, apparently. And a 3 here, then it's 3 meters high. Makes more sense. But you can also, of course, connect these to the elevation model in Allplan. So it doesn't need to be manual. But for this quick example, I've made it manual. The wall width can be defined, and the holes in the wall are already there. Now, you would be thinking, how are these holes generated? Can I change them? Yes. I made use of a randomizer. So in this case, you can enter a different number, and then the holes would also adapt. So you would 23, and you see a completely different random layout of the holes. This is completely random, so I don't know which number will generate what. You have some kind of other options to change the clusters. That is not so important right now. Important thing is when you close, you get this element in the end. Same goes for elements that are already created. So we just created this. Let me quickly remove it. But the elements that we already had on screen can also be edited by just double clicking. And you see that the element shows. The element shows, and the properties will show as well. So I can easily change them. Another example, for example, is I can choose a different material. Let's say this concrete one, and we close it, and now this element is regular concrete instead of the yellowish metal I chose. So this is how you would do it. Of course, let's undo that, because we don't want to change the texture for the whole model. But it's a nice example, I think.
Visual script, what will be the next topic? What is it? The visual sections? It's
no, views and sections. I mean, the elevations.
So is it So is it possible to also generate the sections and views for this
Yeah.
model?
Of course, yeah.
Okay.
So we'll quickly go over that. I would start by maybe loading that favorite we had before. So the one where I set the complete building. And let's close it. So it takes a few seconds. And then our building loaded again. Now we want to make some views and sections of this building. We can easily do that by going to the building structure somewhere. You either make it here or you make it here. It's not so important. You can then say, for example, I want to make some main views. So I already named the files, but they are empty. This is the icon for an empty file. So for example, main views, I open it, I set it active, and I can close it. Now to start making a view, I go back to the architecture module and to views and sections. So there are two options, either generate a section or a view. Let's start with a view maybe. And we need to define on what side we want the view to be. So Allplan is proposing us the front side. I agree, for me this is okay. So I just click somewhere in screen and Allplan is now generating our view. Now, you would maybe agree with me that this view doesn't look all that interesting.
Yeah.
It's a bit, there are some hidden lines, we actually don't want to see them. And it could use some textures as well. So if we double click on that view and go to our formats, maybe let's first start with the background of the elements or the material of the elements. So let's go here for create bitmaps from textures. So that will add textures. We want some transparency. And maybe let's also consider some light. You have some settings for light, but let's not go into that for now. If I would apply this, then in a few seconds, you see that all the materials and textures are actually generated in the model. Now that leaves us with a few small annoyances, of which most of them are the hidden lines. Yeah, we don't need them. So we can go into formats and just say we don't want the hidden edges. So we click here, we apply, and now hidden edges will be removed, and we actually have a view that we can use as a presentation view, I think. It looks really cool. So all textures, also the wood, I have some wood panels defined here, will show. And you can even look inside as we have selected here in the view settings that we want to consider transparency. So transparency is available. We can see the texture inside through the window here. Same applies for sections. So if we go back here, and Allplan really works like we try to put everything on different files to improve stability and to make it faster. So if we want to make sections, let's open a different one. Of course, we can open them at the same time as well. But to make it a bit more clear, let's start with a single one. So this is again our model, and we can generate a section. Now a section is a bit different, and we need to draw a line or a series of lines if we want a section that is broken in a few different parts. Let's start with a simple one. So let's cut from the left side here to the right side. And then we define how deep we want to look. So let's look about this deep, and we can place a section somewhere. Now you see there is something wrong with the section because I'm only viewing a really small part of our model, but you can actually see that the problem lies within this clipping pane. The clipping pane is the actual part that Allplan is going to clip in, so we can adjust this by just dragging in any view up, for example. So let's do that and drag the other one down. And you see, while I'm dragging, the section is actually changing. So this is pretty cool. All sections and views are automatically generated and will adapt to the model. So if you make a change, you will also see that change. So let me go ahead and double click and make a few of the same changes we made before. So we remove the hidden edges. Maybe we can, for the section edges, we can maybe show in a thick line, might look nicer. then it will be like this. So you also see a preview here of what you actually want to do.
Okay.
And let's go ahead and make those things, make those elements textured again. Consider some transparency, some light, and some shadows. So we can apply this, and the section will change. Now maybe you are wondering, do I need to do this again every time? No. You also have, and it's mostly for every function in Allplan, an option to either save it or load a favorite, or to match parameters from an already existing section. So let's close this out. You can see that we are nicely looking inside this building. All elements that have the same material, for example, this slab and this column, will not have a line in between them. This is optional. If you want to see that, you can of course do that. And all textures will nicely show. So on this inside, I chose for a green paneled facade on the inside, and will also show here, of course. Okay. You have the possibility also to add some furniture. We'll not go into that at this time, but as you can see, furniture will have different views in 2D and 3D view and in sections. So this one looks like this if you look here, but if you zoom in, you might see that they are fully 3D. So all the elements are fully 3D, but they are a bit simplified in your section view so that it looks better. So this is automatic. If you choose to create smart symbols, so these are smart symbols. They are provided by Allplan, but you can also make your own. I think same applies for Precast.
Yeah, certainly.
Which you will tell us more about later.
Yeah, you can ask me about Precast later on.
Yeah.
I can share a lot.
So, this is how you would make views and sections. You can of course make them from any angle. There is even the possibility, which might be interesting for special 3D modeled elements, to use, it's on top here, a section along a curve. Yeah. It has a few limitations. You cannot define the depth you want to look in, so a section along a curve will always be
just the surface of it?
Just the surface of the elements. But apart from that, it's a very powerful function. So it's usually a lot used for bridges and other infrastructure elements, while the other sections and views are can also be used for any residential building or commercial building. Now, we have seen how we can easily create an architectural building that looks nice. Of course, we can add some measurements to it if you would like that, but we're not going to do that today. Today, I would like to concentrate a bit on a few new functionalities we also have, where we are going to use Python parts to actually generate reinforcement in a few clicks instead of, as you might remember, we have all these standard functionalities, bar shape and place bar shape, and there are even a few special ones. But today we will focus on using Python parts to quickly create reinforcement so it only takes us a few seconds. Okay. So let's go ahead and do that. We don't need the sections anymore. We will go to our 3D reinforcement part. And you might ask yourself, why did I put it here? This is just to make it clear for myself. You can also put the 3D reinforcement on the left side. This is the building structure that will be exported through IFC. This side will never be exported to IFC. So if you want your reinforcement also exported to an IFC file, you would put it on the left side. Okay, let's maybe go ahead and say, what do I want to reinforce today? We'll start with the first story. So let's take the structure of the first story. This is our structure. If we open our structure, we would see that it contains a few walls, columns, and a slab. And let's open a second drawing file, the first story reinforcement, which is an empty one, and leave the structure active, but this one is the one we'll be driving on. So nothing changes visually, but we are now in a different drawing file. To make it a bit more easy for ourselves to get reinforcement started, I would always suggest to use the object plane and go ahead and try to find the elements that are in our structure. I think now the slab that we see here is a bit doesn't help us much because we want to reinforce the beams and columns, but we cannot see them. So I would always start by going to the object pane and disable those elements, but just in view. They are of course still there, but you can't see them. So we can just click the eye icon here for visibility, and the elements would disappear.
Yep.
So now we only have the slabs and columns visible, and some walls, but that doesn't matter. So we maybe can disable them as well. And this is slabs and columns. Let's go to the 2D screen. Makes things a bit easier. And I'm not going to reinforce everything this moment, but there's actually one more thing I can show you, and that's we can also set the transparency of elements in the object pane. So instead of traditionally going here and,
The surface, right?
and editing the assign custom surfaces or set surface, we can go here and say for the columns and the beams, we want it to be a bit transparent. So now you can see that this would change the transparency, which is a good thing because we are going to add reinforcement. How would we go about adding reinforcement? We are not going to use the traditional tools.
Okay.
We are going to go for engineering structures, and there is a whole section here with automated columns, punching shears in case you ever need it, beams, walls, and wall connections. So that would be a corner of a wall with another wall that would be automatically connected. So let's maybe start with those beams. I would select the beams, and you can just do like this. So I want these beams to be reinforced. You wait a few seconds, and Allplan will add the reinforcement in the beams. Now there are a lot of settings here, and today as a demonstration I will not go over all of them, but to make it a bit clear, you can change all the rebar settings if you want, all the diameters, and even the certain settings for bending pin factor and so on. Also for the stirrups you can define different sections. So in this case all stirrups are at the same distance, but you can of course change this and make it so that the stirrups are actually in the correct position or have the correct distance between them. So for example, this distance could be bigger and this could be longer. So we can change all that, but we're not going to do that. You see it here in the picture that it's possible. Let me just go ahead and close this, and all reinforcement will just be created. Same goes for columns. So we go to column reinforcement, and this option is pretty much the same. If you have a slab above the column, it would also detect it. So let's go ahead and select these columns. And all the reinforcement is added, and as it detected the slab, it says slab thickness is 15 automatically. Okay. So it found out it added some extra bars going out of the top of the columns. So you can see it here. When I close it, it might even be clearer. Now all the rebar elements can be viewed better if you disable the edges. You can see it much better to view. And they all have different colors. These colors can either depend on the diameter, or in my case, I have set the colors to be dependent on the diagram with all the rebar in it. So let me quickly show that. You might already know this, but we can just add a reinforcement bar legend, for example, with our bending shapes. And this would show all the elements. Now we have a lot of them, but actually most of the elements are the same.
Yeah.
So we would like to change our diagram. Well, this goes automatically. We would like to change our mark numbers.
Okay.
We go to rearrange marks, and we can just rearrange them from certain number with certain settings. Click OK, and this would actually rearrange all our bar marks. We'll make it more logical. Now we have 33 pieces of this type of stirrup.
Yeah.
Before, they all had its different mark number. That was, of course, totally unnecessary.
So it summarized all those similar reinforcements in one marking, right?
Yeah, that's what it did, indeed. You can also see it with the colors here. Most colors are actually the same now. So this is how you would do that. Same applies for walls, so let's go ahead and remove this real quick and go back to the object pane. You might remember I can just enable those walls. Walls are now visible. Go for this wall, for example. You can select the wall, maybe this time disable the downstand beams and the columns. We only need the walls, and make the wall a bit transparent. So walls are now transparent, and let's reinforce this. So we can go again to engineering structures and choose for automated wall reinforcement and click this wall. Now we need to be a bit careful because there are two layers and we don't want to reinforce the outside layer, so let's pick this one, and as you can see, the reinforcement is automatically created. So I want to show you one more thing. We have a few extra reinforcement options, and these are the freeform reinforcement options. So for that, let's quickly go to our parking garage entrance. You might not have noticed it yet, but it's this one, our entrance structure.
Okay.
Entrance to the parking garage. And let's go to the reinforcement construction lines. I made the lines with which I made the object. I can also show you that. So let's go to our 3D view.
Are these created as normal lines?
These are splines. So I created some splines in 3D just by clicking a few points. I didn't do anything special for that. And these are some 3D surfaces. Actually, you can already see it here because the object pane is still open. And how would we go ahead now? First, we need some modeling done. So we are going to extrude this surface to that one. So let's go ahead and sweep a path. So let's say we want to connect this path and this we want to connect it to, I'm going to start that again. So let's go ahead and go for sweep path. And we have to select the profiles first. So we can either choose this side or that side, but let's start with this side. And second profile, Allplan is asking, so we want to go to this profile. Now, we have to select some rails. And select two rails. There is one on the bottom and there is one on the top. After that, Allplan will actually create, you have a few options here, but I'll stay out of that, create the 3D object. So this is our 3D object, and let me go ahead and enable these edges again so you can see it a bit more clear what 3D object we're talking about. What we want to do now is go back to that reinforcement function, and we have a few ones, but I'm going for the place bars along surface, and it's asking us to select a reference surface. So let's just select this one, and as we can see, our reinforcement is automatically created with the settings I defined in here. So if you want to change some settings, you can say I only want 40 bars, then it will automatically change at the same moment. So it's a very easy to use function now. And this is how I made the reinforcement for this structure. So if we would go here, because I already made this one, if we go here and go for that entrance reinforcement, we can see this could be a possible end result. Of course, as an example, not everything is correct. I didn't add any connections to the elements, which is of course possible, but this was just an example of that shell function when you see it fully complete.
Basically, we have already these structures, right? So how about the MEP? Are we able to show them about MEP?
Yeah, so you can make a few MEP objects if you want to, but you would use visual scripting for that. Right now there is no dedicated MEP module, but it can be easily done with a visual scripting element. So let's go for, I made some examples here. For the ground floor example, we have some MEP elements, or we enable them both. It might look a bit more visible what I actually mean. So let's close. These are some of the MEP elements. It might not be all that realistic, but I am definitely no MEP designer, and I'm just trying to showcase some of the possibilities. So, how would you go ahead and create these elements or edit the elements? You can just click on an element, double click it, and just like our parametric facade we had before, you have a lot of options here. So in this case, you can choose the profile type. So if I choose the round profile type, you see that it would immediately change and be a round profile. So that's pretty cool, right?
Yeah.
But let's keep it at a rectangular one. I now enabled continuous placement, but you can also just have one element, which would not, of course, be more interesting if you use a bend, for example, to some other place. So there are a lot of options, and this is just something I created myself. So it's definitely not a finished product, but I think there are a lot of possibilities. So if you want to make something for MEP, it's definitely possible.
Well, actually, I tried to do some MEPs, but I created those only 3D objects, basic 3D objects only, not in the Python part, like what you did.
Yeah, this is, of course, parametric, so it helps your workflow. It makes your workflow a lot faster. Okay. Now I want to show you one last thing I think is also important in Allplan, and that's reports.
Yep.
So this was a little sidetrack we went on in the MEP, but we also have reports that we can create in Allplan and use. For example, the spider glass facade we made before, maybe you remember.
Yep.
We can actually generate a report of that facade, which will give us all the elements that a fabricator actually needs. So this report is automatically generated. We haven't done anything, and it will show us all the correct measurements and amount of stuff we need. Now this is the overview report. We also have a more specific report with all elements exactly piece by piece.
Okay.
Here I can just see I need 62 joints, but not what the measurements of the joint are. Such reports are also possible, but I'm showing you the overview in this case. Another example, for example, that was stupid, let me repeat that. Another example is, for example, I do it again. I have some other reports to show you. For example, we have some reinforcement reports. Let's take this British Standard one, for example.
Okay.
We generate that one, and we can see that all the rebar is actually represented with the shape, the amount needed, and this is only for the first story. So you can do this for any story. I only did this for the first story this time. Usually when you make a report, the element, the report you have, you can also select the element in the report and it will highlight in Allplan. I'm not going to show you at this time, but it's possible. Should we add something to this? I think that was it for my part. So, Jayson, this was a small overview. Do you have any more questions?
Yeah, actually, it's a more, for me, because I'm focused more on structural part, and this, what you have shown me is actually more on architectural with the MEP, which really enhanced my knowledge now. At least I know that Allplan can do this kind of things with using this new, let's say, new functionalities.
Okay.
Visual scripting is very, very, I can say, very important now because it's very easy to generate those kind of features.
Yeah.
Right.
Okay. Well, thank you for listening. I also learned something about Precast. Thank you very much.
Yeah, sure. I can share about the Precast. So maybe from your model, I took some of the elements like the walls and the staircase. So maybe I can show you some of this. Okay. So. Okay.
Quick break. So, Jayson, I showed you a bit about reinforcement in Allplan in the engineering module, but I'm actually very curious about the Precast module because it's also included in the basic AEC license, but I have no idea how it works. Can you tell me?
Sure. I can share you about the Precast, but basically I took some models from you, so the staircase and the walls. But for this model, I'll show you first the staircase. So basically, these are just created model from the project. So what I have to do here first is to combine, because as you can see from this model, they are separated maybe, or just an individual element.
Yeah.
So what I'm going to do here now is to combine it with using the normal combination of 3D, which is the union, right? So basically, I'll just click one, and then let's say this staircase flight. And as you can see, I will just right click, and then it will change, of course, the color, and it shows you that it's combined.
Yeah.
Okay, so it's the same process to others, but I will be focusing on this element. Okay, so basically now it's already 3D. This is the best part. You just have to convert it using the precast elements functionality. Just clicking on the precast element icon, and then you have these options where you can define what type of element you're going to convert. And then for this case, I will just choose the element.
And now, can I make different elements myself, or?
Yes, of course, you can customize it on the catalog, and then you can define it as well here.
Okay.
Okay, so after that, once you change, you can put some markings here, which is like a precast staircase, maybe for PST. And then you just have to select this 3D object. So as you can see, it can be highlighted, so it can be convertible.
Yeah.
So just click on it, and you can see that it has a marking, which is an indication that your element is already a precast. Okay, so for this case, as you can see, you have some directions here, wherein you can still modify let's say the point here. You can define this part by just one escape, just to terminate the command.
Yeah.
Okay, just select the element, and then from here, you just point your cursor on the certain point, and then you can define, let's say, just click on this, say, modify reference point.
Yeah.
Okay, so from here, I can just click, and let's say I want to put it somewhere here. So as you can see, there's some orientation, so I just have to rotate it. And then if I escape, it changed already the reference point. And then from here also, I would like to change the orientation or the viewing direction of the staircase. So this is very important in your element plan, because it defines what will be the view in your element plan. Okay, so for this case, I will just change maybe 0, the coordinates, normal coordinates, 0 and then -1, because I want to look it downwards on the plan view, of course. So I just have to say -1. And then, as you can see, it changes the orientation. And on this part, maybe I can just change also this to -1. Again, this is for the orientation on the element plan. So it's
I understand.
very important. Yeah. So I'll just change this to -1. Oops, so better type it in -1 and then 0. So it's just the coordinates. So as you can see, it changed. So it's now facing correctly, downwards and on the left.
Yeah.
Okay.
Also, the label text moved.
Exactly, because you changed already the orientation.
Yeah.
So it represents on the how you want it to be shown. So yeah. So after that, actually, you're already done with the precast element. You can now generate the shop drawing immediately. So you just have to select the element plan icon, and then just click on this precast element, and then you will have your option to define which type of layout you're going to use. So for this case, you can use what I have here. I have created a lot of things, but let me check which one is the best one. So maybe let's try this multiple element, and then say just okay. And now you have it here. So basically, as I mentioned to you, the orientation is it depends on the orientation that you have defined.
Okay.
Okay.
Yeah.
So basically, the 3D model are not that quite right. Maybe we can try to find the suitable so that everything will be complete.
But this is all automatic. I don't have to draw anything.
Exactly. That's the one point. So we just click on the selected the layout, and then you have already the element.
So the only difficult part is the orientation, and apart from that, everything is auto-generated.
Exactly, that's the point. So that's how Allplan Precast can give you a fastest way of creating shop drawings.
Yeah.
So basically, you have this orientation wrongly. So these views can be changed, of course, in the layout catalog, which I can show you, but I will not change it because it will take some time to really correct it. But first, if you have selected it correctly done, then you don't have to redo it one more time. But
So just if you had the orientation correctly, then this would not exist, this problem.
Exactly, correct. So this is just the layout that you can see or you can modify. Okay, so when you create the layout catalog is something like this. So I will not change anything here, just showing you that you have the possibility of creating different kinds of layout. Okay, so we're going back here, and then yeah, so basically we need to put some reinforcements and some fixtures. So I can put some, let's say, basic reinforcement for, let's say, connecting to the slab, right? So as you have shown, you did not use the basic reinforcement, but I will show it on this part because for this we still don't have the reinforcement automatic, but it's not that difficult to do. Okay, so I can say just click on this and then say select the freeform, and then from here you can say, yeah, I can change what kind of reinforcement, of course, bar size, and then I can just say define. So maybe I can change the concrete cover to 25, and then maybe I define something like this.
Yeah.
Right, so just creating the shape of the reinforcement. Somewhere I can just put some tracking line like this, and then say onto here, somewhere here, and then I can just terminate, or I can continue. So maybe I can just continue something like this and then escape.
Yeah.
So you already have the profile, right? Of course, it's not yet done. You have to place it correctly. So I just say right click and then place bar shape. And then you have the option here to define. If you want it automatically, I just click this one. So you can see it gives you automatically the range.
Oh, yeah.
But
depending on the concrete cover, which in this case is zero, I think, no?
So you can change this to, let's say, about 50, just to make sure everything is inside. And then, yeah, that's it. You can just say escape and just terminate it here.
So I don't need to make any views and sections. I can just use the shop drawings to...
So this is the advantage for the Precast element. Once you have generated the shop drawing, you can generate everything there, and it also reflects on your 3D object.
Well, that's pretty cool.
So it really synchronizes the whole thing. You don't need to worry about, oh, I have to change again the shop drawing because I made some modification on the 3D, so it's really synchronized. So another thing here is, once you place the bars, of course, on your report, you can see already the what they call this bar schedule, which is what you have placed in here. It will be shown on your bar schedule. So I can say it saves time to really identify. I have to put some labels. I have to put some I create the shape of this to define in my bar schedule. So it saves time.
Yeah.
Right. So and of course, if you can create some reinforcement on the shop drawing, well, maybe we can complete it using the library. So basically, if I have already some reinforcement pre-made from my previous staircase, then it's the bottom part here. You just pick on the reference point where you save your library, and then you can say click on it, and it also automatically generated here, which of course if you place it you can still move, no problem. So you can say I'll move the reinforcement you placed somewhere this part, so it's not that difficult to modify. And of course it updates also your model, so it's quite easy.
Cool.
Yeah, right. So of course to complete this, I can complete with the whole thing for the what do you call it, the steps. So I'll just pick the correct point again, which is this one, and then of course you can see everything is inside. Well, of course you have to pick the correct point maybe, but anyway, as I said, it's completely easy to place in.
Yeah.
And it also detects on your bar schedule, so nothing's missing. That's the best thing here. And of course, staircase has to be lifted, right? So we need to put some fixtures like the lifting bolts. So it's also easy to place. You just have to define it like from the Precast Elements tab. You have this fixture, this one. So the fixture, and then define from either library or catalog. So for my case, I have it in the catalog, and I can put it on from the project. And I have the lifting anchor. Okay, so I'll just So these are lifting anchors which I already created initially. So because it's commonly used, so I just make it in the library. So I'll just say pick this and then just point it where you want to place it. Say somewhere here. And then if you can see, it detects already the surface.
And it also detects the height and everything, yeah.
Exactly. So I just say OK. And then I have already automatic dimensions of the lifting. So
And also an automatic label, it seems, yeah.
yeah, is it? So it shows you not actually the label, but a reference, like
Okay.
a mark. So it's A, it means your letter A here is your fixture. So again, this is live, so everything is synchronized. So you can see also on the model, it's there. So you can just say, I can copy a mirror. So from this part to some, I just enter it and then rotate, and then you see it doubles. I think it should be doubling.
You didn't copy it?
Let's do it again. It should copy, select, and I say place it correctly here, which let's try to update. It's just an update. Before we update, I just want to show you that there's nothing here. So if I update this one, it should show me something like a detail.
Oh, pretty cool. What is this detail about?
So this detail is actually linked to the fixture that you have placed, which says that if I have this fixture, I will show my detail about that fixture and how you're going to use it, maybe, or what kind of details that you have on this fixture. So it's quite, I can say, intelligent, right? Because he can detect these things and automatically shown up,
Okay.
right? So again, just update, and then you can see the quantity. It's now 2. So you can copy it 2 more so that it'll be complete, but it's just a repeat of the process.
Okay, I understand. It's pretty cool and
Yeah.
very automatic.
So again, you don't have to worry of changing one model and then change again the shop drawing. So that's the best thing here. All right, so this is just an overview of the stairs. It's the same process, so we can go now with the wall. Okay, so again, maybe I can go to a wall and say, this is your wall. Okay, so maybe I can just remove this. Okay, so basically I'm just removing the whole thing here. So it's just your normal wall, okay, from your model. And I just have to do the same thing, convert it to precast element. And then, of course, this element has to be changed to what type.
Yeah.
So this is very important because you have different settings on different type. So
Okay, I didn't know.
okay, so if you have different settings, of course, you have to define it correctly, right? So I select the wall, and then, of course, I need to put some naming here, and then just select the model, which indicates that you already have the precast. And then for this case, I don't want to change the orientation, but I think it's fine. And now, like what we did is with stairs, we need to put some reinforcement, but on this case, I will use our automatic reinforcement. So from here, I will just use the automated wall reinforcement, and then click this wall, and I will have my automatic reinforcement for your
Oh, that's very quick.
yeah, well, that's automatic, of course. So you just have to define the settings here that you need to. As for this as an example, I will not change so much. Just leave it here and just say close, and then you will have your reinforcement. Of course, we can add some more detailed reinforcement afterwards.
And you could also add this reinforcement in the shop drawing, I guess.
Exactly, that's correct. So after that, we can already create the shop drawing as well. So I can say click on the element plan, and then the wall, and then select it, and should change the layout. So maybe I can use the wall multiple layout, something like this one, and it shows me again your automatic shop drawing created. So everything is correctly done. You don't have to change anything. And we're going to do the same. We're going to place the the fixtures, let's say for the connection on the sides. So basically, I presume from the model, we have a column here.
Yeah.
So we can define it. For this case, I already have saved in the library. So maybe I can just use this. Okay. And then here, I will just pick this part, and instead of the shop drawing, I'll put it on the model. So I'll just detect the correct reference point here. And then as you can see, it automatically shows you on your element plan together with the cutouts, which is defined here as well. So I think I need to charge my battery.
Yeah. Are we going to do that now, or
I think
it's almost done?
yeah. Okay. So after that, yeah. So we just need to refresh again because the interesting part is always here. Maybe I can say that. Okay. So basically, the concept of creating shop drawings or precast elements are all the same workflow. So you don't have to worry of what to do next, what to have to put on my element. Do I need to change so much things, which is just a simple workflow and everything is the same.
Yeah, I really like the automatic updates on all the elements, especially the fixtures. Looks really cool.
Yeah, actually the most important thing here for me is the element plan, which shows you everything already, because this is the output of your precast element, which the production guys needs to look at for. So
yeah, it seamlessly connects the 3D and the 2D actually together. Yeah.
True. So modification wise, all synchronized, so nothing to miss out, right? So yeah, that's just an overview of your precast.
Okay. Thank you for educating. Thank you for educating me about some of the precast functionality I didn't know. And thanks everyone for listening.
Thank you.